Hey, how's it going? So yeah, I had this school project recently where I was stretching bioplastics, and in that process, I tried to come up with a way to simulate that stretching, and in Rhino and Grasshopper. I know that there's ways to do it in other 3D modeling software, but I really wanted to try to do it in Rhino and Grasshopper. And I came up with a pretty neat definition using a few different plugins, one of them being Dendro, one of them being paneling tools, and the other one being Calibra, and using a self-optimizing curve algorithm in the Calibra definition. And yeah, I don't know, it created some pretty interesting structures that weren't in the end much like stretching, but I think that it's a cool definition and really easy to use, and someone might be able to take it further than I did. So I'm just going to show you how to create, yeah, those pictures that I shared, and maybe you can do something cooler, and it'd be really sweet to see that. So essentially, what we start off here doing is just creating a plane. You could make this curved and you can make it any shape you'd like, but for the purpose of this video, it's just a simple plane, 100 by 100 millimeters. And then we're giving that plane a rotation, so a start rotation. This is going to be the bottom plate that we're simulating putting material on and stretching it from there. So actually, let's make this like -10. And then we're taking that plane and we're creating a grid of points on it, so 100 points. And then we're using the evaluate surface node and just simply picking a point on that surface. So you can see our point here, and we're just picking a point somewhere on that surface. So it's a little bit computationally heavy, not too bad. All right, then once we have our point, we're giving an attraction or repulsion strength to that point, and as a result, we see the points attract to all the points on the grid attract to that single point. Cool. Let's just turn off these. So now we see that. Turn the plane on. Cool. Oops, not that one. Right, and then we are taking the curve, the geometry, the plane, and those points, and we're going to create another copy of it with a different rotation, and we're going to translate it up in the Z direction. And yeah, so here what we're doing is we're moving both the points and the plane up by 150 millimeters. So we can see that here. It's just basically a copy of what we have below, above. So let's actually make this for the tutorial 250. See something taller. And then what we're doing is we're giving that top geometry a rotation. So let's give it a rotation on XY plane. The YZ plane of 30 degrees. So now we see how that changed the shape. And then on the XY plane, the XY plane, let's give it a rotation of 90 degrees. So and now we have this as our final shape. So now we can just turn those ones off, and we can turn those ones off, and you can see our copy with a rotation on two different axes. So we have all these points here and the same points up here on this surface, and what we're going to simply do now is connect them. So this isn't too difficult. If you go inside this bin here, essentially what's happening is you're taking the original points and the endpoints and you're creating a line between them. And then what we're doing here is we're joining, we don't even need to join the curves. This is because I had multiple planes with multiple points at first and joining them between the two planes and then the next two planes and creating the single curves. It doesn't really matter. Anyways, what we're doing is we're just rebuilding those curves once they're joined to be a degree of 2 and a count of 1 point. This makes it a very simple curve that the simulation can use quite easily. And then we're rebuilding them with 10 points. And that helps, I think, give more flexibility to the curve in the simulation. And then we're building a polyline from those points because the simulation only takes polyline. I don't know if that's the correct way to do it, but that's how I did it. And maybe you might have another idea. Anyways, yeah, what we're doing is just connecting those. And as a result, we have this. Pretty cool. So what I recommend doing once you have that is to bake it to a layer. For instance, the curves layer, get that layer. And then I would just delete any of these outer curves because it's likely that we wouldn't get material forming right on the edge there. But if you're not doing, if you are using this definition with another purpose, you might leave points like that. So in the end, we can select all of those center curves and set disconnect here and set multiple curves here. Cool. Now let's just add those lines and we can see our curves with a nice twist and they're connecting the two planes. All right, so now this part here is the simulation. So this is using Calibra. So far we've used a little bit of paneling tools. Make sure that the display mode here is set to graphic for the simulation. And then if you dive into this bin, here's your simulation settings for a self-aggregating curve simulation, something like that. Yeah, basically just set the, these are like, I've set them so it works pretty well every time. You can play with these numbers, of course. For the scale that I'm working in, these numbers seem to work very well. So if you're working in the same scale as me, go with this. So we can close that. And then we can turn the preview on of this simulation. And you're seeing something from the old simulation. So what you need to do is click this button to reset it. And there we have our first cycle of the simulation. And now we want to run multiple iterations. So we can click this button here till the arrow turns red. And now we're running that self-optimizing curve algorithm in Calibra. So in those blue lines there, we're seeing those results. And if we actually go and, where are we displaying these polylines? We can, whatever. You can see it's a little bit computationally heavy. I think 28, 30 cycles is plenty. So whenever it looks good for you, double click that red arrow again to stop the simulation. And now we can change our display mode to geometry. Let me just make sure that's disabled. Cool. To geometry. Sweet. I'm going to hide these curves. And I'm also going to turn off these points And I'm going to turn off these. Oh, that's the plane. Just hover planes. Cool. So we've done this, we've done our simulation, and now we have changed the display mode to geometry, and now we want to turn on our curve, or our geometry here. So let's click enable, and as a result, turn preview on, we can see how it created this very organic arrangement of those polylines that we gave it using that self-optimizing curve algorithm. Very cool. Right, so we can now, if you want to delete some stragglers, you can bake and reset those curves in this node here. But it looks good to me. So now we're using Dendro. So Dendro is sort of like a plugin that gives you the ability to voxelize your curves or your points in Rhino, and Rhino and Grasshopper, and then convert those voxels to a mesh. It's very computationally not heavy compared to like piping those curves or variable piping to get a similar effect, or sort of like piping and meshing, like Boolean unioning your pipes and smoothing them. So this creates like one nice smooth mesh out of all these curves in the end. Something that you could even print quite easily. Something that looks great for renders, looks great in plans, sections, whatever it is you decide to do with it. So essentially what's going on here is those curves are going into this curve to volume node. There's also points to volume that give a better definition than this, but I find this is very not heavy computationally, so I liked it. This node here takes a setting, and that setting comes from these volume settings here, another Dendro node. Essentially, the most important feature on this node is just the voxel size, and the lower that number is, say between 0 and 1, the more high definition your object's going to look. So let's set it at 1 here, and actually, if we preview this, you don't really see anything, sorry. Let's preview this one now. You can see created these sort of thicknesses around the voxels. If you change this number to like 0.5, you'll start to see how it kind of becomes more high resolution in a way. So just give it a sec. You can see almost like where each of those voxels are. It's kind of creating this like ribbed effect. Anyways, let's go back to 1. And maybe we want to see some gaps in between that. So let's set this to 5. I'm starting to see some gaps. I want to see even more gaps, so let's go 4. I like that. It looks pretty neat. If you don't want it as high res, maybe you could change this up a little bit. That looks cool. And maybe go like 3.5 here. Nice. I really like the look of that. So yeah, once that's done, turn those off. We can do this. We put it in through another Dendro node that's just smoothing it. So we turn that on, turn this one off, and it comes with 4 types of smoothings. So I just play with each of them. You get different effects from all of them. So like in this case, the Gaussian one sort of got rid of some of the material. So you can fix that by making the voxels higher res. There we go. So that's actually quite nice. You could maybe try the other ones as well. You'll see very little difference between them, but I personally like this one. So yeah, and once that's done, then we turn that off and turn our previews on. So this green color here, sort of giving it like a slime-like appearance, and the plates as well, we're giving them a color. I missed the one spot. There's in this definition, this bin here, it simply gives the planes you have a thickness. And so if you dive in, you can set that thickness to whatever you want. So it's 5 millimeters right now. Yeah, so let's go back out and we can turn off every preview over here. Let's have our custom previews. You can maybe give this a cooler color. Honestly, like I kind of want to try red. Okay, that's pretty gnarly. And black. I really want to go with these black sort of. Yeah, it's kind of cool. Sweet. Anyways, I like that color scheme. Yeah, when you're done, you can bake the plates. So I'm gonna bake those guys and set them to their surfaces. And I'm gonna bake this guy and put him in my volume layer. Oops. So bake and bake that and put him in my volume. All right, so that's pretty much that definition. We can hide that and go into Rhino now. And you could prep this for renders. You could start doing some pretty cool stuff with it. So let's go into rendered mode here. Yeah, so it's not like super heavy, this file at all. Sometimes you get these little problems here. That gets fixed when maybe you switch your renderer. So no, it still does it. If you give those a material, I'm sure, I don't know what that is. Yeah, there we go. So if you can give those different materials and it might fix the problem. Make sure it's just clean. And yeah, that's pretty much it, guys. This looks pretty cool in different sorts of views. So for instance, let's go into ISO view here. And then let's go into like a technical view. And you can see you have a pretty good technical drawing of that, very fast, not computationally heavy. Go into shaded, you could create, let's go into front. Okay, don't know why that, oh yeah, because it's on angle. Let's create a clipping plane. And move that clipping plane halfway through. Yeah, and then let's do this. Let's call it section. So yeah, now we have section in our top view here, and it looks like it did a pretty good job of creating a section of a very organic thing. No, like this is something that you could create in ZBrush or Houdini or whatever, another 3D modeling software, but doing it all in Rhino and Grasshopper is pretty handy for having these features very quickly. There's so much you can do with this. I've been playing around with it. I really like this effect, this sort of language, but let's go to this view again and let's go back to perspective. And I don't know, guys, like what if you can take this now, copy it, paste it, without a rotation, scale it maybe like this way, scale it this way. Like, I mean, even delete that and that now, like that's a sick shape. Really, really cool. Super fast and it's very high res mesh. Yeah, like that's pretty cool in my opinion, and that's totally printable. Like we could export that as an STL right now and print it, and it would print fine because it was just curves going straight up and down. There might be a little bit of trouble in certain spots like this. But yeah, it's a really clean mesh. You have one closed mesh that's super organic. So yeah, don't know how to rearrange my C-plane. So I'm just like that, guys. Let's go back to rendered. Look at this really cool thing that we made. And yeah, show all your friends. And please, if you make something way cooler than this, definitely way cooler than this, then share it. And I'd love to see it. Hope you enjoy. Maybe I'll make more videos soon. But if this sucks, I won't. So yeah, take care. Peace.